again, everybody. Welcome back. What we're going to be doing today is now we're going to be looking at two-step equations and how to solve them. I want to remind you that at any point in time in this video, you may pause or certainly rewind in order to slow me down. I am going to go a little bit faster once we get moving in this. So, again, you may rewind or pause at any time. Feel free to turn up the volume or turn it down depending on how loud it is coming out for you. Okay? So, what we're looking at right now is we're looking at a two-step equation, and in this equation, the problem in this case is now it's not just a simple, I can solve it right off the top of my head, I know instead of adding I should subtract, so on and so forth. The first thing that we need to do is we need to identify what our variable is and where is it in relation of this equation. So, what I'm looking for then is where is my variable on this side. So I'm going to draw kind of a line down the middle of my equation because that tells me is it the left side or is it the right side. In this case, I'm looking for n, which n is on the left side of my equation. So this is where we start looking at it and say, do we actually have our variable alone? In this case, in my classes, they will look at it and say, no, I don't, because I'm subtracting 7 from here. I will also ask the question of, do you have 1n? Well, no, I don't, because that's a 3n. So we have two things to do in this case. The first thing in balancing this equation is we have to get this variable, this 3n, by itself. We have to get it alone. And in order to do that, we have to focus in on this negative 7 right here. So how do we get rid of that negative 7? We have to make it 0. The only way to get this 3n alone is to have a 3n plus 0, because we all know any number plus 0 is that number itself. So this is the goal to get to. How do we do that? Negative 7 plus 7, because I use that opposite operation, will get me that 0. Now, by definition then, what I do to one side of my equation, I must do to the other. So there over here, instead of adding 7 to just one side, I have to add it to the 11 as well. Our classes, what we know is we take a look at negative 7 plus 7, we say, hey, that's 0, so I can cross that out. And now I have this situation down here where I can just drop in the 3n. On the right-hand side, I know that 11 plus 7, just off the top of my head, and a simple integer problem, is 18. So step 1 is now done. Step 2 is now we have our 3n alone, but we need to get this 1n. That's the goal. We want that 1n. And in this case, we're not going to actually physically write in the 1, so we already accept that this n is 1n. So how do we do that? Well, if we wanted 1n, if we're looking back to one-step equations, we know we are either multiplying or dividing. And in this case, I have a 3 times n. So now, instead of multiplying by 3, I need to divide by 3. And again, what I do to one side, I must do to the other. So when I look on my left-hand side, I know that 3 divided by 3, and I physically make my kids write this out, is 1. And I always ask my students, did you get 1n? And they'll say yes, because I have those two 1s right there. So that 1n may drop down. I'm going to drop down the equal sign as well. And then now it's just a simple integer question of what is 18 divided by 3, which we all know is 6. Now we found our integer, we have n is equal to 6. So from here, I can make all of my classes check their work. And how we check that work is we have to take what we think our solution is and substitute it back into the original equation. So I'm just going to reproduce the original equation, and everywhere I see an n, I'm going to substitute the 6 back in for it. So in this case, this would be 3 times 6 minus 7, and I'm asking myself, when I compute this left-hand side, will it equal 11? I know that that is 11 on the right-hand side, so I do not change that. I do my order of operations, which in this case, multiplication first. 3 times 6 is 18 minus 7. And I physically make my kids write this out all the time, and they already know this, that I need to see what is 18 minus 11. Hey, that's 11. Does that equal 11? Yep. So therefore, this is correct. And that's how we check all of these equations. We substitute back in. So here's a second practice problem, and now we're going to go a little bit faster. I have to identify where my variable is. I see that it is actually on the right-hand side. So in this case, I have a 7x, so it's not 1x. I also have a negative 3, which I need to have this 7x plus 0. So I need to get rid of this negative 3 by adding 3. What I do to one side over here, I must do to the other in the exact same fashion. Negative 3 plus 3 is 0. So now I did get that 7x plus 0, which equals 7x. And now I have a simple integer problem of what is negative 45 plus 3. And in this case, I think of that song that we've sang in class, which was same signs. Are they same signs? No, we do not add and keep. In this case, we are going to subtract 45 minus 3, which is 42. And I need to keep the sign of my higher number, which is this 45, so that must be a negative 42. From here, I need to get 1x, so I divide both sides by 7, because I know 7 over 7, when I divide that, I'm getting that 1x. So x is equal to negative 42 divided by a positive 7. Negative divided by positive is a negative 6. To check this answer now, here's what I'm going to do. I'm going to write my check up to the right-hand side of this, and I'm going to substitute in this negative 6 every time I see an x, which in this case it's only once. So I'm going to reproduce this equation. Have negative 45, that's not going to change. It's equal to 7 times negative 6 minus 3. From here, negative 45, I have a positive 7 times negative 6, which is negative 42, minus 3. I know that these are same signs in this case, so I have a negative 42 minus another negative 3, so same signs, I add them, and I keep my sign. My answer is then correct. Now what happens if we actually have a division problem in here? Well, any fraction is a division problem. So again, I'm going to go very quickly with this, and it's more the same process, just now it's a different operation in the end. So in this case, I need to get that r over 5, which is on my left-hand side. So I'm going to focus on that side first. I need to get that alone. So how do I get that? I need to make this positive 9 a 0. Yes, again. So this time, to make a positive 9 0, I must subtract 9 from the left and as well as from the right-hand side because I'm balancing this equation. What is 9 minus 9? That is 0. And I'll ask my students again, did we get r by itself? Yes, we did. So we had that r over 5 by itself, and that is equal to 11 minus 9, which is 2. From here, we know if we are dividing this by 5, the opposite operation of that is to multiply. So we're writing that multiplication. And we also call this was a 1 over 5r, which my students would say either keep, change, flip, or flip and multiply, which in this case, I'm going to flip this 1/5 and make it a 5 over 1. And on the right-hand side, I can just make that multiplied by 5 because if I wanted to, I could make these both over 1, but in reality, does it make a difference because they're both whole numbers? No. So I'm going to leave that as 2 times 5. When I look at the 5s on the left-hand side, I can cross-reduce those, make them 1s. So r is equal to, now it's just 2 times 5, which is 10. Now for our check. I wrote the check to the right-hand side right now. So I'm going to substitute this 10 in for r. So I have 10 over 5, or 10 divided by 5, plus 9 is equal to 11. 10 divided by 5, which is my order of operations, is 2 plus 9 equals 11. And then obviously 2 plus 9 is 11. Does 11 equal 11? Yes, it does. Then this is correct. Last question with my classes is they do not, or are not fond of really, fractions. But again, we know ways to get around that. So in this case, we need to get our y, which is on the left-hand side of this equation, by itself, which in this case, to get rid of that positive 18 and make it, you guessed it, 0, we are subtracting 18. So what we do to one side, we do to the other. 18 minus 18 is 0, so we may cross that out and drop down our 1/3 y. So we now have 1/3 y. It is equal to 22 minus 18, which is 4. My students will look at this 1/3 and say, hey, to make that 1y, I have to multiply it by its reciprocal, or they will say flip and multiply. So I have 3 over 1 times 1/3, and on this side, again, I can multiply it just by 3, because we have whole numbers here. The 3's on the left-hand side will cross-reduce because 3 divided by 3 is 1. So did we get 1y? We did. And then 4 times 3 is 12. Okay, now we're going to check this guy. So what I'm going to look at is I have 1/3, and I'm going to substitute in this 12, but I'm going to write it as 12 over 1. I'll show you why in a quick second. Plus 18 is equal to 22. Here's the nice thing about cross-reducing and multiplying fractions. I can reduce 3 and 12 by the common factor of 3. So this 3 down here is becoming a 1. The 12 is now a 4. So now it's 1 times 4, which is just 4 plus 18 equals 22. And then 4 plus 18 actually is 22. Is that equal to itself? It is. Then I know 12 is correct. So I hope that was informational. What you need to do now, out of my students, you need to plug in the correct code for my Google form today. So Mr. Honig students, you are typing in to your form, very simple, all lowercase, Wilson. You will type Wilson in, and that will give you access to the form in which you have to complete tonight for practice. Okay? Good luck, ladies and gentlemen.